IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So the way that is written is X, which will be an IQ score, has the normal distribution with a mean of 100, and then we want to write the variance here, and you can either write the variance as 225 or you can just write it as 15 squared. Either way is fine. So for part A, find the probability that an IQ score is less than 130. Now here is the distribution of IQ scores. The probability that a single IQ score is less than 130 is going to be the area to the left of 130. So we expect a big number here when we calculate this probability. So I'm going to write small because there's a lot to be done on this slide. The probability that the random variable x is less than 130, what we typically do in these cases is we normalize x by subtracting its mean and dividing by its standard deviation. So this is equal to the probability that x minus 100 divided by 15 is less than 130 minus 100 divided by 15. By result number 2, if you take a random variable and subtract its mean and divide by its standard deviation, that will have the standard normal distribution. So I'm going to write that as z. 130 minus 100 is 30, and 30 divided by 15 is 2. Now to calculate that probability, you have to either go to a statistical table or you have to use R. In R, there are two different ways of calculating this probability. The first way is to write p norm of 2. Again, using the p out front gives you the probability that a standard normal is less than 2. That's what we're looking for right here. And this turns out to be 0.9722 to 4 digits. So I'll put approximately in there. Now there's another thing that you can do in R, and what you can do is you can put p norm, and you can go back to the original problem statement and not do all of this work. You can say 130. I want the probability being less than 130, given that my mean is 100 and my standard deviation is 15. That will also give you the 0.9722. Again, what you're doing is you're letting R do all of this standardizing work for you. Now the second part to this problem is find the probability that an IQ score falls between 80 and 110. And that's what I have shaded right here. This is the area underneath the normal PDF of a normal random variable with mean 100 and standard deviation 15. And this is the shaded area here runs from 80 to 110, and that's what we're calculating in part B. So the probability that 80 is less than x is less than 110. Now we could proceed in exactly the same fashion as before. That is, we could take all three of these, subtract 100 and divide by 15. We'd get a number here, we'd get a standard normal right here, and we'd get a number right here. But what I'm going to do here is I'm going to save all of those steps and I'm going to go directly to R to calculate this. So in R, what you will do is you will say this is p norm of 110, and that is this upper limit right here. And the mean, of course, is 100. And the standard deviation is 15. So there is the probability that a normal IQ score is less than 110, but now we have to subtract out the probability that we are less than 80 of 80, and then you want to put those same parameters in. 100 for the mean, and then 15 for the standard deviation. When you do so, what you will get in this particular case, at least to 4 digits, is 0.6563. And then finally, part C here says, well, I'll go ahead and label this. This is 0.6563 is the shaded area that you see there. So for part C, it says to find the 99th percentile of IQ scores, and that is done in R with the Q function, Q norm. And in this case, since we want the 99th percentile, we start out with 0.99. And next we put in the mean, which is 100, and the standard deviation, which is 15. And when you do all that, you will get the 99th percentile, at least to 4 digits of 134.9. So the IQ score that is at the 99th percentile of the distribution lies about right here at 134.9.